Right now, across the Ryukyu Islands, hundreds of thousands of people are either sheltering in place or have already been ordered out of their homes as one of the most persistent and structurally unusual typhoons of the entire season bears down on Okinawa. Naha Airport, the main gateway to the island, sat completely shut down, every domestic and international flight grounded. More than 500 flights across the region were canceled in a single day. Nearly 260,000 residents across Kagoshima and Okinawa prefectures were placed under evacuation orders. Toyota, one of the largest industrial employers in the country, suspended operations at 9 separate factories simply because the storm's reach was wide enough to threaten the shipping routes those factories depend on. And on the ground at Kadena Air Base, one of the largest and most strategically important American military installations anywhere in the Pacific. Airmen and Marines spent the preceding days stacking sandbags, moving aircraft out of the storm's path, and pushing the base into its highest level of storm readiness. This is Typhoon Dolphin, a storm that started its life as an unassuming tropical depression drifting over the open waters of the Central Pacific in late July, and within roughly a week had transformed into the 5th Category 5 equivalent tropical cyclone anywhere on the planet this year, a pace of intensification that is currently running ahead of the all-time global record set back in 1997. Today, we are going to walk through exactly how Dolphin grew this powerful, why it kept getting stronger and weaker and stronger again, in a pattern that genuinely puzzled forecasters for days, what its collision course with an island already reeling from a major earthquake actually means, and what happens next as this storm continues its march toward mainland China. No exaggeration needed here, because the raw numbers behind this storm are already extraordinary enough on their own. Let's go back to where this all started, because the origin story of Typhoon Dolphin genuinely helps explain why it behaves so differently from a typical Pacific typhoon. On July 26th, the storm was still nothing more than a tropical depression, drifting lazily over the open waters of the central Pacific Ocean at around 13 degrees north, roughly 4,400 kilometers southeast of Tokyo, moving west at a modest pace with sustained winds of only 30 to 35 knots. At that stage, nothing about the system looked particularly threatening. But the ocean beneath it was primed for exactly the kind of runaway intensification that meteorologists dread, because this storm was developing directly inside one of the strongest El Niño events in recent memory, a pattern that has been driving unusually warm sea surface temperatures across huge stretches of the Pacific Basin all year. Warm water is essentially rocket fuel for a tropical cyclone, and Dolphin found an almost uninterrupted supply of it as it tracked westward. Within days, the storm had organized into a proper typhoon, and then it did something that immediately caught the attention of storm trackers. Worldwide, it began an extraordinarily rapid intensification cycle, climbing from a modest tropical storm all the way up to Category 5 equivalent strength, becoming the strongest typhoon on record to have developed so close to the international dateline. To put that achievement in context, 2026 has already produced 5 separate tropical cyclones reaching Category 5 strength across the globe, a pace that is actually running ahead of the benchmark year of 1997, when 12 such storms formed over the course of the entire year, a record that has stood for nearly 3 decades. Dolphin's emergence as the 5th member of that exclusive club, arriving less than 72 hours after a separate Category 5 hurricane spun up on the opposite side of the Pacific, is precisely the kind of clustering that climate scientists point to when they discuss how a powerful El Niño event tends to supercharge tropical cyclone activity across an entire ocean basin simultaneously, rather than just producing 1 or 2 isolated extreme storms. What makes Dolphin's story genuinely unusual, even by the standards of an active typhoon season, is not simply that it reached Category 5 strength, but how it behaved after that peak, cycling through a repeated pattern of weakening and re-intensification that kept forecasters revising their outlooks almost daily. The mechanism behind this back and forth is a well-understood but still genuinely dramatic process called an eyewall replacement cycle. Inside any sufficiently powerful tropical cyclone, the innermost ring of thunderstorms surrounding the calm eye, the eyewall, is where the storm's most violent winds are generated. As a storm intensifies toward its peak strength, it is common for an entirely new, larger ring of thunderstorms to form further out from the center, essentially a second eyewall developing outside the first one. That outer ring then begins competing with the original inner eyewall for the storm's available energy and moisture, gradually choking it off. Over a period of hours to a day or two, the outer ring contracts inward, chokes out the original eyewall entirely, and takes over as the storm's new primary wind engine. During this transition, the storm typically weakens somewhat, because the new, larger eyewall spreads the same overall energy across a wider ring, reducing the peak wind speeds near the center, even as the storm's overall wind field, the total area experiencing damaging winds, actually grows larger. Most storms undergo 1, occasionally 2, of these cycles in their lifetime. Dolphin completed 4 separate eyewall replacement cycles, an unusually high number that reflects both how much energy the storm had access to and how long it spent traveling over open water before making landfall anywhere. Each time Dolphin completed one of these cycles, it briefly weakened and then re-intensified, and it was following the completion of its 4th such cycle that the storm re-intensified to Category 4 equivalent strength northeast of Iwoto in the Okinawa Islands on August 4th, with 10-minute sustained winds measured at 215 kilometers per hour, roughly 134 miles per hour, and 3-second wind gusts reaching an extraordinary 260 kilometers per hour, or about 161 miles per hour. Significant wave heights near the storm's core at that point were measured at 16 meters, more than 52 feet, waves tall enough to swamp all but the largest ocean-going vessels caught anywhere near the storm's path. This is also a good moment to explain why a storm undergoing that many eyewall replacement cycles becomes genuinely more dangerous over time, even when its peak wind speed at the very center is technically lower than it was at its absolute strongest point. Each cycle tends to widen the storm's overall wind field, the total geographic area experiencing tropical storm force or hurricane force winds, even as the single strongest gust near dead center eases slightly. Forecasters specifically noted that Dolphin's wind field was widening in a pattern reminiscent of Typhoon Baby, an earlier storm from earlier in the same season that had already caused significant damage and forced the evacuation of well over 1 million people when it made landfall in Zhejiang, China. A storm with a wider wind field spreads its destructive potential across a much larger stretch of coastline and inland terrain, meaning even communities well away from the storm's exact center can still experience damaging winds, torrential rain, and dangerous surf for an extended period. By the time Dolphin approached the Ryukyu Islands, the practical result of that widening wind field was exactly the kind of prolonged, grinding exposure that emergency planners genuinely worry about more than a single sharp, fast-moving strike, because it means the hazard window for coastal residents stretches out over the better part of 2 or 3 days rather than a matter of hours. As Dolphin closed in on Okinawa, the storm entered a gradual, stepwise weakening trend, easing from its re-intensified Category 4 peak, down through the equivalent of a strong Category 1 system by the time its center approached the main island. Japan Meteorological Agency bulletins tracked maximum sustained winds down to around 144 kilometers per hour, with gusts reaching 198 kilometers per hour, as the storm neared a chain of islands between the Kyushu region and Okinawa Prefecture. But weakening in terms of peak wind speed did not translate into a lower overall threat, and Japanese authorities treated the storm with exactly the seriousness its size and slow forward movement warranted. Zoom Earth tracking placed the storm's center roughly 37 kilometers northeast of Kadena Air Base as it made its closest approach, moving on a path that would carry it southwestward before curving northwestward, with an eventual landfall in China projected roughly 60 hours later. That slow, almost crawling forward speed is itself a critical part of why this particular storm generated so much concern among meteorologists and emergency planners alike. A fast-moving typhoon might pass over a given location in a matter of hours, limiting the total accumulated rainfall and the duration of destructive winds even if the peak intensity is high. A slow-moving system like Dolphin, by contrast, can park damaging conditions over the same stretch of coastline for a day or more, allowing rainfall totals to accumulate to genuinely dangerous levels and giving sustained winds far more time to stress buildings, trees, and infrastructure to their breaking point. There's a specific, deeply concerning layer to this particular storm's timing that elevated the entire situation beyond a typical seasonal typhoon threat, and it involves the southern Japanese region of Kumamoto. Just over a week before Dolphin's closest approach to the region, Kumamoto Prefecture had been struck by a significant magnitude 7, one earthquake, an event powerful enough that houses collapsed across the prefecture and roughly 6,700 residents remained displaced in evacuation centers at the exact moment Dolphin began approaching. Japanese officials made the explicit and genuinely important decision to treat Kumamoto's earthquake weakened terrain as a distinct, elevated risk factor entirely, separate from the typhoon's broader impact zone, specifically flagging landslide danger as a heightened concern. This is a critical detail worth understanding properly, because the underlying mechanism is straightforward but genuinely dangerous. An earthquake of that magnitude does not just damage buildings sitting directly on the surface, it also destabilizes hillsides and slopes across the surrounding terrain, loosening soil structure and creating countless new microfractures in rock and earth that would otherwise remain stable under normal conditions. When a major typhoon then arrives on top of that already destabilized ground, dumping heavy, sustained rainfall across the same slopes, the combination becomes considerably more hazardous than either event would be entirely on its own. Saturated earthquake-loosened soil is dramatically more prone to catastrophic landslide failure than undisturbed ground, experiencing the same rainfall total, and that is precisely why Japanese emergency management authorities issued specific elevated landslide warnings for Kumamoto separate from their standard typhoon guidance for the wider region, recognizing that residents there faced a genuinely compounded hazard that most coastal areas further from the earthquake's epicenter did not have to contend with. The compounding disaster scenario unfolding in Kumamoto also deserves a bit more attention because it illustrates a broader challenge disaster response agencies increasingly have to plan for: the reality that natural hazards rarely arrive neatly spaced apart on a convenient schedule. A region still actively managing the aftermath of a major earthquake, with thousands of residents still displaced and structural inspections still ongoing across countless damaged buildings, has dramatically less institutional capacity, fewer available personnel, and less physical shelter space to absorb a second major disaster arriving on top of the first. Emergency management resources that would normally be available to support typhoon evacuation and response in an unaffected region were instead already stretched thin, supporting ongoing earthquake recovery efforts, forcing local authorities to essentially run two simultaneous disaster response operations with a single, already strained pool of personnel and equipment. This is exactly the kind of cascading, compounding disaster scenario that emergency planners across seismically active, typhoon-prone regions like Japan increasingly have to build into their contingency planning, rather than assuming each hazard will arrive in isolation with adequate recovery time in between. The scale of the human response mobilized ahead of Dolphin's arrival reflects just how seriously Japanese authorities treated this storm, even as its peak wind speed eased somewhat during its final approach. Evacuation orders covering nearly 260,000 residents were issued across Kagoshima and Okinawa prefectures, spanning the Amami region, Okinawa's main island area, and the more remote Daito Islands, sitting further out in the storm's broader wind field. Local governments across the affected islands issued clear, consistent guidance, urging residents to secure loose objects around their homes, stay well away from the coastline, given the dangerously elevated surf, and prepare for extended power outages and disrupted ferry and flight service throughout the storm's passage. By the time the storm's outer bands reached Okinawa's main island directly, roughly 240 people had already taken shelter in official evacuation centers, and 3 men in their 70s had sustained minor injuries, 2 after being caught directly by the wind, and a third after falling from a stool while attempting to prepare his home for the approaching storm, a small but genuinely telling detail about just how dangerous even the preparation phase of a major typhoon can become for anyone caught outdoors in gusting winds. Japan's national broadcaster reported specific concern about the potential formation of a linear rain band, a narrow but extremely intense corridor of concentrated thunderstorm activity, capable of dumping extraordinary rainfall totals over a relatively confined area in a short period, precisely the kind of localized deluge that has triggered flash flooding disasters in Japan in past years, even when the broader storm's overall rainfall total looked comparatively moderate on paper. Ferry service across the outlying islands, a genuine lifeline for many smaller communities that depend on scheduled sailings for everything from food deliveries to medical transport, was suspended well ahead of the storm's arrival, and residents of the more remote Daito Islands, sitting further out in the storm's broader wind field, faced an especially difficult calculation given how limited emergency shelter and medical capacity tends to be on smaller, more isolated islands compared to Okinawa's main population centers. On the American military side, the response was equally methodical and equally telling of how seriously this storm was regarded well before it made its final approach. Installations across Okinawa, including Camp Foster and Kadena Air Base, elevated to their highest tropical cyclone readiness condition, meaning forecasters expected sustained winds of at least 58 miles per hour to arrive within the coming 12 hours. Personnel across multiple bases spent the preceding days stocking emergency supplies, positioning sandbags at building entrances, and relocating aircraft away from the projected path of the storm's most dangerous winds. At Kadena specifically, maintainers from the 708th Aircraft Maintenance Squadron prepared HH-60W Jolly Green II helicopters and KC-135 Stratotanker aircraft, ensuring that critical assets remained mission-capable and ready to support any evacuation or emergency response operations the storm might ultimately require, even while the broader wing simultaneously conducted a previously scheduled readiness exercise running in parallel with the real-world storm response. The Navy relocated aircraft assigned to installations across Okinawa well ahead of the storm's arrival, and officials from Fleet Activities Okinawa were explicit in public statements that the safety of personnel, their families, and military hardware remained the absolute top priority throughout the response. It is worth understanding why American forces treat a storm like this with such institutional seriousness, even when the eventual peak winds at Kadena itself turned out to be closer to Category 1 strength than the storm's earlier Category 4 or 5 peak. And the answer comes down to the base's outsized strategic importance. Okinawa hosts one of the densest concentrations of American military infrastructure anywhere outside the continental United States, and any prolonged disruption to flight operations, fuel supply, or personnel readiness there carries consequences that extend well beyond the immediate weather event itself, which is exactly why installations across the island treat even a weakening storm system with the same disciplined, methodical preparation they would apply to a system still near its peak intensity. The broader economic ripple effects of Dolphin's passage extended well beyond the immediate storm zone as well, offering a useful reminder of just how interconnected modern supply chains have become, with weather events unfolding thousands of kilometers from a factory floor. Toyota's decision to suspend operations across 9 separate manufacturing facilities in mainland Japan reflects a lesson the automotive industry has learned repeatedly in recent years, that a major typhoon disrupting shipping routes through the region can just as easily halt vehicle production as a direct strike on a factory itself, since modern manufacturing depends on an extraordinarily precise, continuously flowing supply chain that a single major disruption to regional shipping can bring to a standstill within days. More than 500 individual flights were canceled in a single day as Japan Airlines and All Nippon Airways, the country's 2 largest carriers, canceled service to and from Naha Airport well ahead of the storm's actual arrival, a decision made not simply out of caution for the immediate storm window, but also to reposition aircraft and crews ahead of what forecasters correctly anticipated would be an extended, multi-day disruption to normal flight operations across the region. There is another dimension to this storm worth understanding: the sheer difficulty forecasters faced in nailing down Dolphin's exact track even just a few days out, and it offers a genuinely useful window into how tropical cyclone forecasting actually works behind the scenes. Early in the storm's life, multiple competing scenarios remained genuinely plausible in the model guidance, with different major forecasting centers, the European model, the American GFS model, the UK Met Office model, and Japan's own regional model, each showing meaningfully different outcomes ranging from a direct strike on Okinawa to a track that stayed further offshore and recurved harmlessly out to sea before ever threatening land. That kind of model disagreement is completely normal for a storm still several days from any potential landfall, since even small differences in how each model represents the atmosphere's current state can compound into significantly different projected tracks a few days down the line. What eventually broke that uncertainty was watching how consistently the models began converging as Dolphin's structure became clearer, and as it moved closer to land, exactly the kind of narrowing confidence that forecasters rely on to time evacuation orders correctly, issuing them early enough to give residents genuine lead time to prepare, but not so early that people evacuate a threat that ultimately shifts elsewhere and never actually arrives, which would understandably erode public trust in future warnings. So where does Dolphin actually go from here? And why does the answer to that question matter just as much as everything the storm has already done? Having passed north of Kadena Air Base and continued its slow, grinding transit across the Ryukyu Islands, forecast models converge on a track carrying the storm southwestward before executing a northwestward curve, ultimately aiming toward a landfall somewhere along the eastern Chinese coastline, roughly 60 hours after its closest approach to Okinawa. That curving track matters enormously for exactly which populations end up facing the storm's remaining energy, since a system that has already spent so much time cycling through eyewall replacements and grinding across island terrain typically continues a gradual weakening trend as it approaches its final landfall, even as its overall wind field remains unusually wide by typical storm standards. Chinese coastal provinces, having already weathered Typhoon Bobby's landfall in Zhejiang earlier in the same season, an event that required the evacuation of more than 1.7 million people, now face the prospect of a second major storm arriving within a relatively short window, precisely the kind of compounding seasonal stress that regional emergency management systems increasingly have to plan around as this particular El Niño-driven typhoon season continues generating one significant system after another. It also helps to understand exactly how forecasters measure and communicate a storm's strength, since the terminology involved, Category 4, Category 5, Super Typhoon, can genuinely confuse anyone not closely following tropical weather regularly. The Saffir-Simpson scale, used across much of the world, sorts storms into 5 categories based purely on sustained wind speed, with Category 4 covering sustained winds between about 209 and 251 kilometers per hour, and Category 5 covering anything faster than that, regardless of the storm's size, its rainfall totals, or its overall destructive potential. Different national weather agencies also use slightly different methods for calculating sustained wind speed itself, with the U. S-based Joint Typhoon Warning Center measuring winds averaged over 1 minute, while the Japan Meteorological Agency and most other national agencies around the Pacific measure winds averaged over 10 minutes, a methodological difference that can make the exact same storm appear to have meaningfully different peak wind speeds depending on which agency's bulletin you happen to be reading. That is precisely why dolphins' reported wind speeds shifted somewhat depending on the source. Not because the storm was actually behaving differently, but because different agencies were applying different averaging windows to the same underlying data. Understanding that distinction is genuinely useful for anyone trying to follow a storm's progress across multiple news sources without getting confused by numbers that appear to disagree with each other. It is also worth noting how storm surge and elevated wave activity, rather than wind alone, drove much of the coastal danger throughout Dolphin's approach, since the storm's very wide wind field meant that dangerously large swells were reaching shorelines across the region well before the storm center itself arrived. Significant wave heights of 12 meters, roughly 40 feet, were recorded near the storm's track, even as its core winds had already eased from their earlier Category 4 peak, a reminder that a weakening storm can still generate genuinely life-threatening surf conditions along exposed coastlines for a considerable stretch of time. It is worth stepping back at this point to place Dolphin within the broader context of what has genuinely been an extraordinary year for tropical cyclones across the Pacific Basin, because understanding that wider pattern helps explain why forecasters have been tracking this particular storm with such heightened attention from the moment it first began organizing. The direct link between a powerful El Niño event and increased tropical cyclone intensity in the western Pacific is well established in the scientific literature, and it operates through a fairly intuitive mechanism once you understand the underlying physics. El Niño's warm phase shifts the pattern of ocean surface temperatures and atmospheric circulation across an enormous stretch of the Pacific. And during a sufficiently strong event, that shift tends to expand the pool of unusually warm water available to fuel developing storms, while simultaneously reducing the amount of disruptive wind shear that would otherwise tear a strengthening storm apart before it reaches its full potential. The result, in a year like this one, is not simply a slightly more active season on paper. It is a genuine clustering of extreme intensity events, storms reaching a Category 4 and Category 5 strength, at a pace that outstrips what a typical year would produce. And Dolphin's emergence as the fifth global Category 5 equivalent storm of the year, arriving within days of a separate Category 5 hurricane forming on the opposite side of the Pacific Basin, is exactly the kind of pattern that meteorologists specifically flag as consistent with a strong El Niño signal rather than simply an unusually active but otherwise ordinary season. It is also worth putting Dolphin alongside recent storms that followed a similar track through this exact stretch of ocean, because the comparison genuinely helps illustrate what made this particular system stand out. Typhoon Kanin, which struck the same general region back in 2023, was itself a powerful, erratic, and long-lived storm that rapidly intensified into a Category 4 equivalent system over the Philippine Sea before undergoing its own eyewall replacement cycle, and eventually tracking along Okinawa in the Korean Peninsula over an unusually extended period. Kanun became a textbook example at the time of just how much cumulative damage a slow-moving, erratic typhoon can inflict simply by lingering over the same general region for days rather than passing through quickly. Dolphin followed a broadly similar playbook: an initial burst of rapid intensification, a slow and erratic period of eyewall cycling, and an extended grinding transit across the same general chain of islands. And forecasters explicitly drew on the lessons learned from storms like Kanun when planning the extended multi-day evacuation and readiness posture adopted across Okinawa this time around. That kind of institutional memory, carrying forward specific lessons from one difficult storm into the response plan for the next one, is a large part of why the human toll from Dolphin, at least in terms of the Okinawa portion of its track, remained limited to a small number of minor injuries, despite the storm's genuinely extraordinary peak intensity earlier in its life cycle. It is also worth being honest about what a storm like Dolphin does and does not tell us about the broader trajectory of tropical cyclone activity going forward, because overstating any single storm's significance would do a disservice to the actual science involved. A single extreme season, however dramatic, does not on its own prove a permanent shift in global storm patterns, since natural year-to-year variability driven by cycles like El Niño and its cooler counterpart La Niña has always produced periods of unusually intense activity followed by quieter stretches. What Dolphin does represent, alongside the broader 2026 season's remarkable pace of extreme intensity events, is a genuinely useful case study in exactly the kind of storm behavior scientists expect to become more common as ocean temperatures continue trending warmer over the coming decades. Storms that intensify faster, sustain their peak strength longer through repeated eyewall replacement cycles, and arrive with unusually wide wind fields capable of stressing infrastructure and emergency response systems across a much broader geographic area than a typical storm of similar peak intensity would have a generation ago. That broader trend, storms behaving this way more frequently rather than this exact storm being unprecedented in isolation, is precisely why meteorological agencies across the Pacific region have been investing so heavily in improved rapid intensification, forecasting, and extended evacuation planning capacity in recent years, recognizing that the margin for error when a storm can transform from a modest tropical system into a Category 5 monster within roughly a week has grown uncomfortably thin. For anyone living across the region currently in Dolphin's path, or anywhere along the Pacific Typhoon Corridor more broadly, the practical guidance emergency management officials have been repeating throughout this storm's approach remains exactly as relevant now as it was when the first evacuation orders went out. Secure or bring indoors anything outside your home that wind could turn into a projectile, since flying debris remains one of the leading causes of storm-related injury, even in storms that ultimately weaken before landfall. Stay well away from coastlines and low-lying areas prone to storm surge and dangerous surf, even after the storm's peak winds have technically passed, since elevated wave heights and dangerous rip currents frequently persist for a day or more following a storm's closest approach. If you live anywhere near terrain recently destabilized by seismic activity, treat landslide warnings with the same seriousness as wind and flood warnings, since saturated, earthquake-loosened slopes can fail with very little additional warning once heavy rainfall begins. Keep a charged phone, a battery-powered radio, and several days of water, food, and any necessary medications on hand well before a storm's arrival, since power outages following a major typhoon frequently extend well beyond the storm's actual passage, sometimes for the better part of a week in the hardest-hit areas. And if local authorities issue an evacuation order, treat it as time-sensitive rather than optional, since the window for safely relocating ahead of a storm's most dangerous conditions is often measured in hours rather than days, particularly for a slow-moving system whose most intense rainfall bands can arrive well ahead of the storm's actual center. Typhoon Dolphin's story, from an unremarkable tropical depression drifting over open Pacific water in late July to the 5th Category 5 equivalent storm on the planet this year, to a storm that cycled through 4 separate eyewall replacement cycles before finally weakening its way across Okinawa and toward an eventual Chinese landfall, is ultimately a story about exactly how much energy a sufficiently warm ocean can pour into a single weather system, and about the genuinely impressive scale of coordinated human response, from evacuation orders covering hundreds of thousands of residents to military installations moving aircraft and stacking sandbags days in advance, that a storm of this caliber now reliably triggers across a region that has learned, through hard and repeated experience, exactly how seriously a storm like this needs to be taken. The storm is not finished yet, and the coming days will determine exactly how much additional rainfall, wind damage, and disruption the remaining stretch of its track delivers to communities across eastern China, still recovering from an earlier storm this same season. If this breakdown helped you understand exactly what has been happening with this storm and why forecasters have been watching it so closely, go ahead and hit like so it reaches more people trying to follow this story as it continues developing. Subscribe if you want to keep tracking Dolphin's final track and the broader Pacific typhoon season as it unfolds, and drop a comment letting me know if you or anyone you know has experience with a typhoon like this firsthand, because those firsthand accounts genuinely shape what we dig into next. We will keep tracking this storm closely as it makes its final approach toward the Chinese coastline, and we will be back with an update the moment the picture becomes clearer. Stay safe out there, and we will see you in the next one.